हाय फ्रेंड्स, आज का टॉपिक है यूनिफॉर्म एंड नॉन यूनिफॉर्म मोशन. सो टुडे वी विल लर्न what is uniform and what is not uniform motion. So let's start. First of all, what is uniform motion? See, as the description mentioned here, uniform motion. When an object covers equal distance in equal interval of time, it is said to be uniform motion. Friends, see, there are a point O, point A, a point B, and a point C. A car starts moving from point O to point C. When he covers from 0 meter to 4 meter, he takes 2 seconds. Similarly, when he covers the distance from 4 meter to 8 meter, he takes 2 seconds. Same way, from 8 meter to 12 meter, it takes 2 seconds. So we can say this car is moving, or this car is taking similar distance for covering same time. Like 2 seconds takes to move 4 meter, again he takes 2 seconds to move 4 meter, again he takes 2 seconds to move 4 meter. So I can expel that when an object, or it may be object, it may be body, it may be plane, it may be cycle. So when an object covers equal distance in equal interval of time, remember friends, there is a equal interval of time in same time and same distance, equal distance and equal interval of time, it is said to be uniform motion. I'll give you one more example. See, suppose there is a car at point 1. This is the point 1. Okay. Suppose this is point 1. This is point 2. This is point 3. This is point 4. So these cars start from point 1 and moves 10 meter and reach point 2. So the distance 10 meter he covers in 2 seconds. Similarly, from 10 meter to 20 meter, again he takes 2 seconds. See the distance, you can measure here. This distance, and this distance are same. See, the difference is 10 meter, 20 meter and 30 meter. So he takes 2 seconds here. Sorry, he takes 2 seconds here. He takes 2 seconds here. It takes 2 seconds to cover this distance also. So this cars move from point A to point 2, he takes 2 seconds and moves 10 meters. Similarly, from point 2 to 3, he takes 2 seconds and take 10 meters. Similarly, from 3 to 4, he covers same distance in same interval of time. So it is called as, yes, right, uniform motion. And I will give you an example. Suppose if someone asks you what is the example of uniform motion. So the best example of uniform motion is hand of clock. Everyone, mostly everyone wearing the clock, hand watch or wristwatch. So at every second, this red needle covers equal distance in every second. So it is the best example of uniform motion. As you can see, when clicking, it covers from 7 to 8. He click 5 times and he covers same distance, same interval time. Similarly, from 8 to 9, 9 to 10, 10 to 11, 11 to 12. Or one more example I can give you. See, there is a spring, it is clamped on one end, and this circular path this point is following this point. See, once you focus this points, as this point going up, this ball is coming here upside. When this spring's ball comes down, this again comes down. So as the spring balls moving, similarly this circular balls also moving. So it is a it is a uniform circular motion. This is the example of uniform circular motion. It's an example of linear motion, linear uniform motion. This is the circular uniform motion. So this circular uniform motion is not in your course, okay? It is on 10th standard. So in your course there is only uniform, non-uniform in linear motion. So this is the best example of linear motion. This is the best example of, see, this point coming down, going up, coming down, going up. Similarly, this was coming up, coming down, coming up, is covering equal distance every time in a given time period. Okay, so this is the graph of uniform motion. If we'll draw a graph between distance and time for uniform motion, it will come like this. This is time, this is distance. When you draw a graph, it will come a straight line. A straight line is in the sense as the time increases, the distance also increases uniformly. Similarly here, as the time increases, the distance also increases. So this is the example of, this is the graph of uniform motion. And one more graph I will show you for the uniform motion. See, this is the time and displacement graph. When the time is 1 second, the displacement was 10 meter. Similarly, when the time is 2 seconds, the distance is 20 meter. When the time is 3 seconds, it is here. This displacement is 30 meter. When time is 4 seconds, it moves 40 meter. So this is the graph of uniform motion. So आप लोग को समझ में आ गया होगा यूनिफॉर्म मोशन क्या होता है. Now you can understand what is the uniform motion. Next we will come to the non-uniform motion. See, what is the non-uniform motion? Non-uniform motion, when a body travels unequal distance in equal interval of time. See, there was in uniform motion, it was equal distance in equal interval of time. Here unequal, here it is unequal distance. Here it is unequal distance in equal interval of time. In uniform motion, there was equal distance and equal interval of time. Here it is unequal distance in equal interval of time. It is called as non-uniform motion. See, in first case, a car moves and a car takes similar distance in similar interval time. Okay, but in non-uniform motion, a car takes suppose 2 seconds to reach from point 1 to point 2 and again takes 2 seconds to cover the distance of this much only. So this is the time is same, taken 2 seconds, 2 seconds, but distance from 1 to 2 and 2 to 3 when it takes, this distance is lesser than this distance. So when unequal distance in 2 seconds it takes to cover, suppose this is 10 meter and this is 5 meter, and time taken both same, 2 seconds, 2 seconds. So there is unequal distance. So this is called non-uniform motion. This may be greater than 10 meter also, may be greater or lesser. See, it takes 10 meter 2 seconds to travel 10 meter. Again you can take same 2, because this equal interval of time, so time will remain same. 2 seconds you can travel 5 meter, you can travel 15 meter, you can run 20 meter. So that is non-uniform motion. For non-uniform motion, I will show you one graph. See, this is the example of non-uniform motion. There is a car at point 1, this is point 1, this is point 2, this is point 3, this is point 4, and the distance between here to here, it is 5 meter, and from here to here it is 10 meter. 10 meter means 15 minus 5, so 10 meter. And similarly 15 to 30, here it is 30 minus 15, it is 15 meter. So the equal interval, this is also 2 seconds, this is also 2 seconds, this is 2 seconds, this is also 2 seconds, this is also 2 seconds. So time equal interval means time is same. Here it takes 2 seconds, here also it takes 2 seconds, here also it takes 2 seconds. But the distance cover, first 5 meter, again 5 to 15 any 10 meter, again 15 to 13 any 15 meter. So first 2 seconds he covers 5 meter, next 2 seconds he covers 10 meters, next 2 seconds he covers 15 meters. So this car is covering unequal distance in equal interval of time. That is called non-uniform motion. Okay, I will show you the graph of non-uniform motion. See, the non-uniform motion graph is this curve type. This is the curve of non-uniform motion. See, when time was 2 seconds, the distance covered is less than 10 meter. It is near about here. Okay, when the time was 4 seconds, then also it was lesser than 10 meter distance. When it was 6 meter, then I think it is near about 10 meter. When it is 8 seconds, then it was more than 10 meter. But it is non-uniform distance. So distance is 10, 20, 30, 40, 50, 60. It is a non-uniform motion. So non-uniform motion, you can get the curve like this. Now I'll ask you one thing. Can you tell me what are the difference between uniform and non-uniform motion? It's very important. So if you're having any confusion, you can read this thing. See, this is uniform motion, this is non-uniform motion. Here in uniform motion, movement of a body is along the straight line with constant speed. Means suppose there is a point A and there is a point B. So the car moves this from A to B in a straight line, and he takes equal speed. I mean the speed the car from point A to B remains equal. If he is running from 10 km per hour, so at every point of the line his speeds will be at 10 km per hour. Okay, it will not vary. And in non-uniform motion, movement of body or object or car is along the straight line with variable speed. Here speed is varying. Suppose from point A, suppose this is point A and this is point B. So the variable speed means if he covers from point A to point B, the speed here, if you measure 10 km per hour, here you will see some changes. It may be 12, it may be 15, it may be 18, or it may be 5. So the speed is variable. So that is called non-uniform motion. So in non-uniform motion, movement of a body is along a straight line with variable speed. Next, a uniform body covers equal distance in equal interval of time. It is similar as I told earlier. So in uniform motion, a body covers equal distance in equal interval of time. Similarly, In non-uniform motion, body does not cover equal distance in equal interval of time. Next, speed of the object is similar to the actual speed. Speed of the object is similar to the actual speed. Here, speed of the object is different to the actual speed. Next, the graph between distance and time is a straight line. Okay, and non-uniform motion, the graph show curved line. This type of motion, there is no acceleration. It has zero acceleration. The acceleration I will explain you in the next lecture. So I think you understand what is the difference of uniform motion and non-uniform motion. So next I will give you some example of uniform motion and non-uniform motion. When I will teach you some numerical problem, then you will clearly understand what is the uniform. It will clear your doubts what is the uniform and not uniform motion. So there are some example of uniform and non-uniform motion. So first we will start from uniform motion. So best example of uniform motion is a car going along a straight road at constant speed. A car is moving along road at constant speed. And second example is a train going along the track at constant speed. A train moving on the track at constant speed, that example of uniform motion. Next, the movement of fan. Yeah, see, when we switch on our room switch, the fan moves. The fan moves at a uniform motion, starting when it runs after 2 or 3 seconds. When it takes higher speed, it's move a constant speed. Okay, so the movement of fan is also in uniform motion. Next, cooling fan running at a fixed speed. Okay, now non-uniform motion. Non-uniform, the movement of asteroid. Asteroid, you know what is asteroid? In space, lot of asteroids are there, so they are moving with non-uniform motion. A bouncing ball. Yeah, this is the best example of non-uniform motion. You take a ball and drop it from 1 or 2 meter above height, and the bouncing ball will come down. It will take some time. Again he bounce. He will cover some distance, but remember, it will not cover the equal distance from where you drop the ball. Okay, so it will come down. Again it will go up. Again it will come down. The speed of the bouncing ball may increase. So it depends upon the material of the ball. Either it is plastic or it is rubber. So it will cover lesser distance in same interval of time. So this is the best example of non-uniform motion. Next, the train coming to its terminating SOP. The train coming, it is not coming continuous speed, constant speed, terminating speed. Next, dragging a box from a surface. Yeah. Take a box or take any object and drag it on a surface. The surface is not fully furnished. It is rough surface. When you rub it and move, it is a non-uniform motion example. So thank you friend. I think आपको ये वीडियो अच्छा लगा होगा लेक्चर. अगर आपको ये फ्रेंड्स अच्छा लगा है तो आप लाइक बटन क्लिक कर सकते हैं, से अपने दोस्तों के साथ शेयर कर सकते हैं और सब्सक्राइब करना ना भूलिए, क्योंकि आपको लेटेस्ट अपडेट मिलता रहेगा. सो क्लिक ऑन सब्सक्राइब, शेयर एंड लाइक. थैंक यू फॉर वॉचिंग.